companies that are utilizing it to help drive are the ones that are much more transformational and having more success.
Hey, what's up YouTube? Jeremiah Hersey here, and welcome back to another PL300 test question. Today we're going to be dealing with the different merge types inside of Power BI, and to do this I'm going to use something that was created by SQL.json to be able to help us understand the different merge types. So we're going to go through that first, and then we'll go through the test question. I'll also put a link in the description so that you can play around with this visualization to understand the merge types. Let's go and get started. So here we are in the Microsoft community page, and we're looking at this visualization created by SQL.json to understand the different merge types within inside of Power BI. So the first one is a left outer join. So as we look at the tables here, so we're looking at table A and table B. So this is how we're going to understand the merge types. And we've talked about this in several other videos. The idea is that we have to identify what is going to be the key column between the tables, or the column that relates the two. And so as we see here, the customer ID is going to be the link between table A and table B. And so we're just going to go through the different join types relatively quickly. Once again, I'll put the link in the description, so if you want to play around with this and get a better understanding, you can as well. And so as we look at these tables, we see that customer ID number 1 here in table A is not available over here in table B. And so the way that these joins work inside of Power BI, it's based off of identifying that key column. And so with a left outer join, the table A is going to be our left table. So this is going to be our left table here, and on the right hand side is going to be our right. So as we look at this, it's going to take everything from the left table. So a left outer join takes everything from table A and anything that is matching from table B. And so the first thing it looks at is the first row. And so customer ID of 1 is Brad Pitt. And so we can see that here in the resultant table down below, customer ID 1 is Brad Pitt. Because there is no customer ID of number 1 in table B, it does not return an email address, which is why it's blank. Then we move on to row number 2. So we see customer ID of 2. This does match in table B. So customer ID 2 matches, and so therefore it is going to return the value of the email address from table B. It goes on to do customer ID 3 and 4 as well. Now, the interesting thing here is as we get to customer ID of 4, notice that there is 2 of them. So what it's going to do is it's going to identify, okay, Angelina Jolie is customer ID 4, and there are actually 2 related records for customer ID 4. That is why you see 2 records here with 1 of each email address. The same thing is true when it gets to Jen Aniston, customer ID of 4. It's going to have those 2 values once again for the 2 email addresses, and so we'll see 2 related records for Jen Aniston as well. So it uses this key column to identify relationships and to return the associated information. The next is a right outer join. This is the opposite. It's going to take everything related in table B, so everything from table B and anything that is matching from table A. So it's just the opposite. We're going to use this right table first, and then anything matching. So anything matching 2, 4, or 5 is going to get returned. Notice that in the resultant table down below, we don't see customer ID of 1 because it is not associated to that key column. The next one is an inner join. So inner join is only the matching rows from both tables. And this is the most optimized join inside of Power BI. So as we look at this, we have 2 and 4 are the only ones that match with inside of this table. And so only customer ID of 2 and 4 for matching rows, that's an inner join, is going to be returned. As we look at a full outer join, you can see everything is returned from these tables. Additionally, you'll also see that down here, once again, we have the 2 email addresses associated to both customer ID of 4 with that customer name. So a full outer join is all rows from both tables. As we start to look at the anti-joins are basically anything that is in table A that is not in table B. So as we look at our left table, which values are in table A but not in table B, and that's going to be Brad, Pitt, and Julia Roberts. Those are the only 2 that are in this table that are not in table B. The right anti-join is similar, except it's going to look at the right table first. So once again, as we look what customer ID is in table B but not in table A, it's going to be that customer ID of 5, which is not associated to any customer inside of table A. And then finally, we have this full anti-join. So this is going to be rows only in table A and not in table B, combined with rows only in table B and not in table A. And so in that case, it's going to look, okay, customer ID 5 is not associated inside of table A, and additionally, customer ID of 1 and 3 are not associated in table B. And so you can see that resultant table down here at the bottom. So now that we have a better understanding of what's going on with these joins, let's take a look at our test question. It says in Power Query Editor, you have 3 queries named product category, product subcategory, and product. Every product has a product subcategory. This is a good piece of information. Every product has a product subcategory. But additionally, it tells us not every product subcategory has a product category. And so we need to merge these 3 queries into a single query or table, and the solution must ensure the best performance inside of Power Query. So when we're trying to understand how we want to merge these tables together, we have to think about how they're related and what's going to be the best join type to optimize the performance, because that's the key with this question. So as we look at the first section here, product and product subcategory, we have to determine what is the best join type. And so it tells us in this first part up here at the top that every product has a product subcategory. So for this first one, every single product will have a subcategory associated to it. Now, when we think about the join type to optimize performance, this inner join type is going to be our best performing. So while, yes, we could do a left outer join with the product and subproduct category, the inner join, which is going to take every matching row from product related to product subcategory, that's going to be our best performing join type. And so for this first one, we're going to do an inner join. So we have our product and our product subcategory. We're going to inner join them, matching rows from both tables, but we're already told that every single one of these will have a match guaranteed. That was in the question here at the top. So now we have to look down to the next part. It says product subcategory and product category. So our left table here, this is important. So as we look at this diagram, this is our left table. So our left table is product subcategory, and it says that not every product subcategory has a product category. So there are going to be some blanks in here when we complete our join type. And so as we look at this and understand that we need all of the information from product subcategory, and it's the left table. So immediately we can eliminate the right joins. We can also eliminate a full outer join as well, because we know that we don't need all of the information from both tables. We only want to pull back the information where it's related, and because of that, we are going to be looking at one of our left joins. Now remember that a left anti-join is everything from table A that is not matching in table B, and so in this case this would return the null values. That is not what we want. We want to return the values associated with subcategory to that product category. And so for the second piece, we are going to be looking at a left outer join. So this left outer join will take everything from product subcategory and anything that is matching from the product category and bring it over. Anything that is not related will return a null if it is not related. And so as we start to understand how we're going to combine these tables, once again, we could have tried to do a left outer on this first product and product subcategory join, but that inner join, because we know that they're going to be matching, is going to be the best performing. I want to thank you so much for joining me in this question. If you like this video, give it a thumbs up and subscribe to my channel for more content. I'll see you in the next one.